Hi everyone, today's objective is exponential regression model. So let's take a look at some of the pictures. You put in your data and you use exponential regression. And here is the example on the TI-84. The exponential regression is at the 0 and you will have the form. Look at the equation form is a times b to the x power. It even tell you a and b. So now going on, the next is in the previous 2 units we have looked at the linear regression right here and the quadratic regression feature on the calculator, and there is also a exponential regression feature that we can use if we think data are exponentially related. So right here, right there. Okay, example 1, use the data in the right to answer the following. So here's the data to the right. A, use the exponential regression feature using technology to fit an exponential model to the given data rounded to 3 decimal places. All right, so please pause. Can you find the equation just like the same as mine and try to answer some questions. Letter A, I punch in the calculator like what we did for line regression and quadratic regression. The only difference is I just pick up number 0 and then I will get the number with A, B, and even the equation form listed, and I just plug in the numbers. So 80.227 is going to be your A, and B is going to be 0.889. So therefore, I put the equation down as follow. Right here. This is my A. 0.889 is my B. That's my multiplier. And X stands for my T. Second question asks, what does the value of A represent in the context of this problem? What the context in this problem is how much caffeine do you have in your bloodstream? And in this case, at the initial of drinking of the caffeine, you have 80.227 milligram represent the initial that is in the bloodstream after the intake. Letter C, what does the value of B represent in the context of the problem? The context of the problem is 0.889 milligram of caffeine disappear after every hour has passed. So the caffeine is disappear 0.889 milligram every single hour passed. D, rewrite the equation in part A in the form of AT equals P times 1 plus R to the T power. Now don't forget, you also have a P times 1 minus R. Because it's decreasing, we're going to use the minus instead of plus. So to do minus, I have to do 1 minus whatever that's disappearing. Now the disappearing part is going to be 1.11. It goes down by 0.111. And 80 is going to be what you start off with. And T stands for years. So D, write the equation in part of the form A, T equals P times 1 plus R. Now in this case, it's going to be 1 minus R from the previous note. The reason for that is because it's a decay to 80.227. That's the initial amount based on the calculator. Then 1 minus 0.111. I took 1 minus 0.899. And that's how I got the 0.111. Letter D, what is the approximate constant percentage rate of change given by the math? Well, the constant percentage rate, that means it goes down by 11.1% because we have 89.9% left every hour goes by. So what has left the body? Well, that's going to be 11.1%. Letter F, what does the answer E mean to the context of this problem? Every hour, 11.1% of the caffeine disappears in the body stream. G, predict how much caffeine is left in the bloodstream after 14 hours. So 14 hours is going to be the T. So that's why I put down the T position, and then this is the formula I plug it in, and then 1 minus 0.111 because that's how much it left the body. After I punch in the calculator, this is how much caffeine has left after 14 hours. So that means all those other ones have left the body and 15.491 is left. That's 0.899% in the parenthesis. H, use the intersect feature on the calculator or the table on the calculator to estimate the half-life of the caffeine. round the answer to the nearest whole number. You are going to put in the equation. I'm going to write down all the equation for you and discuss it. The calculator, please enter y1 equals 80.277 parenthesis 0.899 to the t power, or use the x. Y sub 2 equals 40. Then hit graph. To get the graph, you might have to use zoom fit, zoom standard, or zoom out to play around, but make sure you get both lines. Second, calculate number 5 intersect. That's intersect. Then they will ask line 1 or curve 1, curve 2, and guess. And you just press enter on all of them and you will get your answer. And the answer for that, for letter H, is after about 5.92 hours, there will be the 40 shows up. That's where the intersect. And then so in this case, since they say round the answer to the nearest whole number, so therefore we are rounding to 6 hours. If you round it down to the 5 hours, it will not reach 40, which is 50%, which is half life or half the caffeine that's left. After 6 hours, when we round up, 50% of caffeine will be out of the bloodstream, and that will be your number 1. Please try example number 2. It's the same type of problem. And come back and then we will talk about it. Hi everyone, today we are going to discuss 6.8 inverse functions. A function says that for every x, where is exactly one y, that is y value can be duplicated, but x value cannot be duplicated. If the function has an inverse, that is also a function, then there can only be one y for every x. So here's the definition. Definition of an inverse function. We have spent a lot of time in this course with functions and answering two main type of questions. 1. What is the output for the given input? 2. What input will give us a particular output? Which of this was easier to answer? Recall the following definition of a function. Definition of a function. For every input, there is exactly one output. If you are given a graph of a relation, we would see if the graph passed the vertical line test. We have looked at many input-output tables. Throughout this course, such a table describes relations between variables. When each input has exactly one output value associated with, we call this relation a function. If you were to reverse the inputs and the outputs in such a table, you will get another way to describe the relation between two variables called the inverse relation. Sometimes this inverse relation is also a function. When the inverse relation is also a function, the original function is called the invisible. Okay? All right, let's look at example number 1. In example number 1, it says, consider the following relation. Answer the following questions. Is this relation a function? So take a look at your x. All right, is any of the x value repeated? No. So since they are not repeated, this is a function. And then explain, yes, it is a function, and then explain is because none of the x value was repeated. B, fill in the table below for the inverse relation. Really, what you have to do is just take your f of x, put it in the x position, take your x position, put it in your f of x position. So really it's going to be just -2, -1, 0, 1, and 2. That's really your x. And then this is going to be 4, 1, 0, 1, 4. And that is going to be your fx. Now the question asked, is this relation a function? No. The reason is because the x value was used twice. So if you look at B real quick, you will see that the 4 and the 4 and the 1 was used twice. So the new x value was used twice, so therefore it's not a function. For letter D, I'm just going to show you in the table so you can see what it's like. It asks, look at the graph of fx equals x squared. Here's your graph. Does each input has a unique output? And in this case, if we pass the vertical line test, it's going to be a function. So does it have an input, unique output? The first part is definitely yes. Now the problem is, can we tell if the second part is also yes? So let's write in the table and then see if we translate the number, is it going to work the same way? So I'll pause my video and then show you what I wrote down. So for the first one is yes. The second one is no. If you notice, I put down the table on the first graph, the table, all the points that's from the black parabola. Now I did this side, which is 1, 1 and 2, 3 and 3, 9. And then I didn't do the negative sign because I kind of figure if I have to flip this, I probably have some idea. But if you want to go on, you can do negative 1, 1 and negative 2, 3 and negative 3, 9. So I did one side and then I flipped them. So my 0, 0 stayed the same, my 1, 1 stayed the same. But notice my 2, 4 become 4, 2. My 3, 9 become 9, 3 because that's how you do a inverse. Now once I graph this second one, which is the inverse, I get the parabola on the top. So I know the parabola is going to go on the bottom this way. So therefore, if I run the vertical line test, it's going to be a no. So that's not letter D. Let's go on to example number 2. And you guys try it because they are exactly the same thing and see you guys get the same answer. So pause the video. So for example number 2, here's the answer. The first one, yes, it is a function because every x only was used once. All right, and then so for the second one, notice that I flipped the x and the f of x, and so every x is only used once. So therefore, it's going to be yes for the function, and the x value is only used once. So the next one I'm going to try to figure out is x and y gonna switched. Does input has a unique output? Yes, because you can do the vertical line testing. If you do the vertical line testing, you can just draw it and you only hit the graph at one point. And does the output has a unique input? Well, let's think about this. The line is going to be at 1, 1, x and y. So it's going to be 0, 0, 1, 1, 2, 2, 3, 3. So then when you flip it over, that's going to be f of x and x. That's still going to be 0, 0, 1, 1, 2, 2, and 3, 3. So of course, they are going to be the same exact thing. That's going to be a function. All right, or you can think about it, x become y, y become x. So of course they are. So going on to reading through some of the information. In this case where the inverse relation also is a function, it would be nice to have a formula for that inverse function. Then to answer the harder question about input leads to particular output, we could just use the inverse relation and answer the easier question about what output you get for that input. If inverse relation is a function, we have special notation for the new function. Give a function f if its inverse relation is also a function. We use the symbol f of inverse. That's called the inverse, f inverse. As the name of this new function, the symbol f of -1 is f inverse. Okay, so in this case, when you have an inverse function, when this all works, what we're going to use is f of inverse. So you have to have original is a function, and when you do the inverse, that's a function. Then we do f of -1, which is f of inverse. Okay, and then so that moves on. So here's example number 3. Let's go through example number 3. Again, make sure you check and then same rules apply from example number 2. So here's the answer for example number 3. Again, you just flipping it, and because we realize it is a function, so therefore it's totally okay to write an f of the inverse x. Now, the ABC, what we're going to do is we are going to look at the tables and pick out our number. The first one, it says f of 2. That means the regular function is going to be f2. So f of 2 is right here. So the answer is 4. Inverse. F of the inverse is 2. So f of inverse is 2 right here. So therefore, the answer is 4. And then f of inverse is -4. And then if that's -4, which is going to be right here, the x is -4, and the answer is going to be -2. And that is how you look at the answer. Depends on the location of the f of x, depends on the inverse notation. So make sure you know what you are looking for. So letter B says f of inverse is 2. So f of inverse is 2 right here. So therefore the answer is 1. The next one is f of inverse is 4. F inverse is 4. So therefore the answer is, if 4 is 2, not -2. Sorry. Right here, f of inverse is 4. And then it's going to be 2. All right. And then going on, so in this case, you're looking for the ones that has f of inverse. This is f of inverse x value plugging in here. And then this is the y value coming out. This is the y value that's going to be recorded. All right. So now what you're going to do is it says property of an inverse function. If the inverse function of f is a function, we can call that function f of -1, which is f inverse. And the following statements are equivalent. F of a equals b. F of -b, see that? That b, it's just flipping it, equals a. F of the inverse b equals a. So f of a equals b, f inverse b equals a. Just flip it back. If AB is a point on the graph of the f, then BA, literally just flipping it, will be the point on the graph of inverse, f of inverse. So example number 4, the function CX gives the cost the thousands of dollars to produce X item. Interpret each of the following in the context of this problem. So letter A says C is 50 equals 12. So 50 is going to be the input. 12 is going to be the output. Then the next one says, so what does it mean in this case? What does it mean in this case is when 50 items were made, the cost was $12,000. It says that when 50 items were made, the cost was $12,000. That's input, amount of items. Output is how much money. Now, since it's the inverse, that means we are putting the output. This is used to be output. So this is the dollar amount is going in there. And this is going to be the items. So what does it really mean? Is going to be when 60 items were made, the cost was $14,000. The 14 is the dollar amount. The 60 is how many items because we switched them around. So the translation is when 60 items were made, the cost was $14,000. So that is example number 4. Going on to example number 5. Please fill out your table B for the f of the inverse. So here is the answers for example number 5. I took it half to the 0 power, which is 32 times 1 equals 32. And if you 1 is actually half of 32, and it's going to be 16 and so forth. That's how I get the numbers for this column for the f of x. Then I switched over, and then that's just pretty much switching it. And then the first question at C asks what's f of 2. When you f of 2, so therefore f of 2, that's the x value, that's going to be a. Then inverse of the 2. So if you look at inverse of the 2, inverse of the 2 is right here. And that's, oh, I'm sorry, inverse of 2 is right here. So it's going to be, and thank you so much for watching. And that concludes today's notes. And thank you so much for watching.